Our new topic is compound angles and double angles, which starts on page 39. And what we're going to do, you're looking at compound angles. So fundamentally, we can actually cos of A plus B. We can actually prove this as a theorem, and which is cos A cos B minus sine A sine B. Now if we take that as our fundamental, then you are looking at cos of A minus B, derivation of cos of A minus B. So what we make it, rewrite it as cos of A plus minus B, and then you'll notice the A is A but the B is minus B. So wherever we have the B, we'll put minus B, and that now changes that formula to cos of A minus B is cos A cos B plus sine A sine B. Then you could also derive sine of A plus B from this. Now if you take sine of A plus B, your derivation basically would be sine and cos are complementary, so sine of A plus B is cos of 90 minus A minus B. So what we basically do is make that the first angle, and that would be the second angle. So your first angle, and we can use now cos of A minus B formula, which is cos A, and that becomes 90 minus A, and cos B, and then you got plus sine A, which is sine of 90 minus A, and sine B. Now cos of 90 minus A is sine A, cos B plus cos A sine B. Now I actually derived the formula for you, and then you can see the next one is sine of A minus B is equal to sine A cos B minus cos A sine B. Down to this is a useful derivation, and one couldn't understand why it was taken out of the curriculum, but it is now coming in very disguised ways. 2.1, which is tan of A plus B. Now tan of A plus B is sine of A plus B divided by cos of A plus B. Tan is sine over cos. So if you use the expansions very quickly, you will get sine A cos B plus cos A sine B. Now, and the denominator is cos A cos B minus sine A sine B. Now if you divide each term of this expression by cos A cos B will cancel off, you'll get tan of A, plus you will get tan of B, and cos A, dividing cos A cos B by itself will get 1 minus cos sine of A divided by cos of A is tan of A, tan B. And now 2.2, then therefore it follows that 2.2, the tan of A minus B, the signs will only change, which means that it will become tan of A minus tan of B all over 1 plus tan A tan B. Now we're going to do application. Now that you know the expansions, and also you should know the reductions, what we're looking at is 3.1.2, and what is 3.1.2 is sine of 105 degrees. Now we can split that up into two special angles. Now that is the whole idea of these compound angles, and they would split up into 60 degrees plus 45 degrees. Now it says without the use of the calculator even in your ordinary work, so it means you have to do it as special angles. And that is sine A, sine 60 cos 45 plus cos 60 sine 45. And all we need to do now is that's root 3 over 2, and that's root 2 over 2 plus a half times root 2 over 2. And when you add up all that, you will get root 6 plus root 2 all over 4. We're looking at compound angle application 4.1.3. Now 4.1.3, if you look at that, we need to reduce them to acute angles, and sine of 115 is sine of 65 degrees, and then cos of 20 degrees, we'll keep that as is. Now sine of negative 335 is negative sine of 25 degrees, and negative sine of 25 degrees, you'll get negative sine of 335 degrees, and then because that's in the fourth quadrant, you will get again, you'll get a negative times negative is positive, so it will not impact. So it's minus sine of 25 degrees. And now you'll notice we've got cos of 70 and we've got cos 20. So if I make the sine 20, because they're complementary ratios, 70 plus 20 is 90. Then I can do this now strategically. Sine 65 cos 20 minus cos 65, which gives you angle A, and sine 20 degrees. So you got sine A cos B minus cos A sine B, which is actually sine of A minus B, and that gives us sine of 45 degrees, which is root 2 over 2. Now if you're looking at 4.1.4, the problem there is you got 15 degrees and 75 degrees. So we must try to use the idea of A plus B and A minus B. So what I can see here, it's cos of 45 minus 30 times cos of 45 plus 30. Now when we do the expansions for both, what we can do strategically is to write it as cos 45 cos 30 plus sine 45 sine 30. And then it's multiplied by, so let's write it down. So it will be cos 45 cos 30 minus sine 45 sine 30. So if you look at the product of these two expressions, you will notice it's like difference of two squares. So if it's difference of two squares, then it will be cos 45 cos 30 all squared minus sine 45 sine 30 all squared. Now that will become root 2 over 2 times root 3 over 2 all squared minus root 2 over 2 times half all squared. And that when you square them, you'll get 6 over 16 minus 2 over 16, and that will give us 1/4. Problem is 4.2 on page 39, and it is sine A and cos B are given. So what we normally do is we take the sine, which is y over r, and you'll notice that x, theorem of Pythagoras, x is equal to 9. So, and then here cos is x over r, and then if we use theorem of Pythagoras, then we get y equals 8. So we got the xy and r values for the angles, so the ratios become very easy. 4.2.1 is sine of a minus b is sine a cos b minus cos a sine b, and you got sine a is 40 over 41 times cos b is 15 over 17 minus cos a, which is x over r, 9 over 41 times sine b, going to the next one, the sine is y over r is 8 over 17, and when you work that out, you'll get 528 over 697. And then 4.2.2 is cos of a plus b, and that is cos a cos b minus sine a sine b. Now cos a is x over r, 9 over 41, and cos b is 15 over 17 minus sine a is 40 over 41, and sine b is 8 over 17. So when you work that out, you get minus 185 over 697. And then looking at the next problem, there is tan of a plus b. Tan of a plus b is tan of a plus tan of b all over 1 minus tan a tan b. And then you've got 40 over 9 plus 8 over 15 all over 1 minus, substitution there, 40 over 9, that's y over x, times 8 over 15, which is also y over x. Now when you simplify this, you will get minus 672 over 185. Now remember this, some of them may say you can't use the 10, you can use it. But then if it means that you'll have to go back and work from first principles each time. Right, this problem here is 4.6 and it is on page 40, and once again it is similar to the cosine one, except for here you've got the addition. So which means that it is sine of 45 plus 30 plus sine of 45 minus 30 degrees, and that gives you here sine a sine 45 cos 30 plus cos 45 sine 30. Now remember I said we just write the plus sign here, and then you've got sine 45 cos 30 minus cos 45 sine 30 degrees. Now if you add those, you'll notice the plus cos 45 sine 30 will be eliminated. So you end up with 2 sine 45 cos 30. And this is the same as saying 2 times root 2 over 2 times root 3 over 2. And that gives you root 6 over, the answer is root 6 over 2. .8 on page 40. Now you'll notice there it seems to be like tan A plus tan B. So what we can do is to reconstruct this problem. Cos of tan is sine over cos, so we have to change it. So that is sine of 25 degrees complementary over cos 25 degrees, and this is in the third quadrant, which is tan of 20 degrees, positive tan of 20 degrees, all over 1. Now tan of 155 is minus tan 25 because that's the second quadrant, and then cos, that is now that is sine 20 degrees over cos 20 degrees, and that gives you, using complementary, so that's tan 25 degrees plus tan 20 all over 1 minus tan 20, tan 25, tan 20. That's commutative property, and that gives us tan of A plus B, which is 25 plus 20 degrees, and that's tan 45, which is 1.